All right, we're going to be going over the test review. Okay, so here we go. So for this first section, sorry, this is in the way, I apologize. Okay, for this first section, there's a couple things you need to know. One, you need to recall your formulas. Okay, so cosine equals x, sine equals y, tangent equals y over x. Secant, which is the reciprocal of cosine, is equal to 1 over x. Cosecant is equal to 1 over y, and then cotangent is equal to x over y. Okay. You also need to remember your families. So 30 degrees is equal to root 3 over 2, comma 1/2. 45 is equal to root 2 over 2, root 2 over 2. And then 60 is equal to 1/2 root 3 over 2. And so when you find reference angles, you'll either get 30, 45, or 60. Okay, our formula for reference angles is in quadrant 1, theta minus 0. Okay, in quadrant 2, 180 minus theta. Quadrant 3, theta minus 180. And quadrant 4, 360 minus theta. Remember, reference angles are always between 0 and 90 and always positive. Okay, so cosine for 300 degrees, that's in quadrant 4. So if I do 360 minus theta, that gives me 60. My reference angle is 60 degrees. Okay, so that means I'm using 1/2 over root 3 over 2. Okay, now I'm in quadrant 4 there. So in quadrant 4, x is positive, y is negative. Okay, and so what is cosine equal to? Cosine is equal to the x value, so cosine of 300 degrees would just be 1/2. Okay, secant 150. 150 is in quadrant 2. 180 minus 150 gives you 30 degrees. So you know then this is your ordered pair for 150, except 150 is in quadrant 2. So x is negative, y is positive. What I suggest to do is I would find cosine first, okay, and then just flip it to get secant. So cosine at 150 would be a negative root 3 over 2, which then you flip, gives you a negative 2 over root 3, which then you multiply top and bottom by root 3, and you get a negative 2 root 3 over 3. Okay? Cotangent of pi over 6, memorize unit circle. You know that that's 30 degrees. Okay? So since that's 30 degrees, the nice thing is that in quadrant 1, you don't have to find a reference angle. You already have your families here. So that's root 3 over 2, comma 1/2. Both stay positive because in quadrant 1, x is positive, y is positive. So then what is cotangent? Cotangent's x over y. Okay, so we're going to have this. We're going to have root 3 over 2 all over 1/2. Which when you do that, you're going to get root 3 over 2. Change the multiplication, flip, 2 over 1. The 2's cancel out. There and there like that, and then you're left with root 3. Okay? Sine of 360, that's quadrantals. Okay, so sine of 360, so 0 and 360 is 1, 0. So my ordered pair here is 1, 0. If it was 90, it'd be 0, 1. If it was 180, it'd be 0, it'd be negative 1, 0. Sorry, 180 is negative 1, 0. And then 270 would be 0, negative 1. So sine is just equal to the y value. And the y value in this ordered pair then is just equal to 0. Okay? Tangent is 7 pi over 6. That is 210. So 210 falls in quadrant 3. So then your reference angle is 30 degrees. So I'm using, since it's 30 degrees, I'm using root 3 over 2, comma 1/2. Okay, again, we're in quadrant 3, so both are negative because x and y are negative. And so tangent is y over x. So I'm going to do 1/2 over root 3 over 2. So that means you do 1/2 times, change to, because it's division, right? You're dividing fractions. So you do 1/2, change to division, change to multiplication, and flip. So those cross out and you're left with 1 over root 3, which then you need to then rationalize top and bottom. And so your final answer is root 3 over 3. Sorry, I know that's hard to tell, but there you go. It's root 3 over 3. Okay. We did number 6 in class. This ends up being a negative 300, which when you add 360 to it, you get 60 degrees. Why am I adding 360? Because I want it between 0 and 360, so I can use my unit circle, which again, I will be giving out a blank unit circle tomorrow at the beginning of the test, and you will be able to fill it out. Okay? Okay, so we now have 60 degrees, so we know our possible answer, ordered pair using 60 degrees, is going to be 1/2 root 3 over 2. Okay. Cosecant is 1 over y, or I would actually find sine, because sine is the reciprocal. So find sine first. So sine is 60 degrees. Okay. And again, we're in quadrant 3 here, so that's, quadrant 1, so that's why positive, positive. Okay. I actually made a typo on tangent, but tangent is actually negative, negative, so it does become positive. Your answer does in quadrant 3. Sorry about that. Okay, back to number 6, though. Okay, so find sine first is 60 degrees, which is root 3 over 2. Then to find cosecant, I'm just going to flip. And so when you do that, we already seen that. I did it already. It's the same as number 2, except it's just positive this time. So 2 over root 3. Okay? All right, 3 pi over 4. That's the same thing as 135 degrees. So that's quadrant 2. 180 minus 135 is a reference angle of 45 degrees. So here's your ordered pair. It's root 2 over 2. 2. Okay, we were in quadrant 2, so x is negative. And now cotangent is equal to x over y. So we just get negative root 2 over 2 over root 2 over 2. They're the same, so you just got, it's just negative 1. Okay? Don't worry about doing number 8, no calculator version. That is 810 degrees, which then you would have to subtract 360 a couple of times. And so when you do that, it's okay. I'm just going to pass on. When you subtract 360 twice, you end up with 90 degrees. So it's a quadrantal. Okay? All right, same thing here like in number 6. That's a negative 150. We add 360 to that. We get 210. Okay, 210's in quadrant 3. So to find my reference angle, that's 30 degrees. So we know that my reference angle is root 3 over 2, comma 1/2. Okay, and so again, we're looking at secant, so find cosine first. So cosine of root 3, we're in quadrant 3, so negative, negative here. So cosine of 210 would be negative root 3 over 2, which then, but we want secant, so we flip it, negative 2 over root 3, which we had this for secant of 150, and so your final answer is just negative 2 root 3 over 3. Okay. Now we can start using our calculator here. Okay. 72 degrees. Okay, so we just do 72 times pi over 180. Make sure you plug that in. So you just do 72 times fraction button, pi over 180. Enter. And you get 2 pi over 5. Okay, we want to change radians to degrees. We're going to take that 11 pi over 12, and we're going to multiply it by 180 over pi. Again, fraction button, 11 pi over 12. I know you're not seeing it on the screen, but I'm doing it as well as I'm saying right here. So 11 pi over 12 times 180 over pi. Enter, and you get 165 degrees. Okay? All right, remember, arc length is theta equals S over R. Okay, so let me scroll up here. So theta equals S over R. So remember, theta is equal to the angle measure right here. R is the radius, and S is the length around the arc. So when we look at this first one here, we've got theta equals S over R. It gave me S and R, so we know then that theta is equal to S, which is 14, over R, which is 6. Biggest thing that I forgot to mention is that theta is in radians, so 14 over 6 simplifies to be 7 over 3, and we write 7 over 3 radians. Okay, the perimeter. So this right here, this is a radius. This right here is also a radius because it's a point from the center to a point on the circle. So these two have to be the exact same. So this is 6. This is 6 because of the problem before. S is 14. And so I'm trying to find the perimeter of this sector right here, outlined in dark. So that means then the perimeter is equal to 6 plus 6 plus 14, which equals 26, and then I just said units. Okay? Find the exact arc length in sector area of the intercepted arc in the circle. Okay? So again, we're trying to do arc length first here. We're trying to find S. So there's our formula, theta equals S over R. Currently, as constructed, I don't have R. We do have the diameter. So if the diameter is 30, the radius is half that. So the radius is 15 centimeters. Okay? Theta is 150. You need to change that to radians. So if you don't recall that from your unit circle, you multiply by pi over 180. And you're left with 5 pi over 6. So now we have R, now we have theta, we can find S. So let's plug in everything we know. We have theta in radians, so we have 5 pi over 6 equals S over the radius, which is 15. Cross multiply here. So you go 6 times S, which is 6S. You go 5 pi times 15, which equals 75 pi. Divide by 6 here. And so you get S equals 75 pi over 6, which simplifies down to be 25 pi over 2 centimeters. Okay? Same thing here. Area is equal to 1/2 theta R squared. Okay? So when we do that, we're going to get 1/2 theta in radians. Again, remember, it has to be in radians. Your calculator needs to be in radians for this. Radians. Okay? 5 pi over 6 times the radius squared there. That'll give you 1,125 pi over 12, which then simplifies to be 375 pi over 4. Okay? Determine two... Oh, here, let me scroll up now. Determine two coterminal angles, one positive, one negative, for each 45-degree reference angle between pi. So there are two angles on your unit circle that are between 180 and 360 that have a reference angle of 45 degrees. If you're not 100% sure, go around your unit circle and use your rules up top there. But for time purposes, that first one is 225. Because 225 minus 180, you're in quadrant 3, gives you 45 degrees. Okay? So a positive coterminal angle, remember, coterminal angles, all we're doing is we're adding and subtracting 360. So 225 plus 360 equals 585. Okay? Your negative 225 minus 360 equals a negative 135. Okay, that other angle in quadrant 4 is 315. That has a reference angle of 45 degrees. Okay, so again, same thing here, positive. You're just going to take 315 plus 360. And you're going to get 675 negative 315 minus 360 negative 45. And there you go. So that's one positive, one negative coterminal angle. Okay? All right, so find the other 5 trig ratios of theta if sine theta is equal to negative 5/13 and cotangent is greater than 0. So I need to find where my triangle falls based on these two. They have to have something in common. What quadrant do they have in common? Okay? Well, real quick here, if you use your unit circle, okay, we use our unit circle, our quadrants here. We know in quadrant 1, x is positive, y is positive. Quadrant 2, negative x, positive y. Quadrant 3, negative x, negative y. Quadrant 4, positive x, negative y. So what this tells me is that I'm looking to see where sine is negative. I know of this ratio, I just want to know where sine is negative. So sine is negative in what quadrant? Sine is always equal to the y value, so it looks like sine is negative in 3 and 4. Quadrant 3, quadrant 4, okay? And then I want to know where cotangent is positive. Well, remember, cotangent is equal to x over y. So that occurs in quadrant 1 and in quadrant 3 because a negative divided by a negative gives you a positive. So what do they both have in common here? Quadrant 3. So now I can go ahead and know that this right here falls in quadrant 3. So I can go ahead over here and I can draw a triangle. So how do I get to quadrant 3? I go left, down, theta goes in the corner there, and here we go. So now I know two sides of this triangle because I was given the ratio by sine. So remember, sine is equal to opposite. Oh, I don't know why I did theta there, sorry. Opposite over hypotenuse. So my opposite side is negative 5. My hypotenuse is 13. Okay, for purposes, I don't have enough room here. Pythagorean theorem, when you do Pythagorean theorem, you should get 12. Remember though, because you're in quadrant 3, x and y are negative. X, y. X, y, they're both negative. Okay? So now that you have all three sides, you can just use SOHCAHTOA to figure out the rest of your ratios. So cosine is adjacent over hypotenuse. So your adjacent side is negative 12. Your hypotenuse is 13. Tangent, opposite over adjacent. Okay? So your opposite side is negative 5. Your adjacent side is negative 12. Negative over negative gives you a positive, so just 5 over 12. Cosecant we're just going to flip, so it's just a negative 13 over 5 because that's the reciprocal of sine. Secant we're just going to flip cosine because that's the reciprocal of cosine. So negative 13 over, technically put the negative sign just down here in front. Negative 13 over 12. And then tangent reciprocal is cotangent, so we're just going to flip it. And you get 12 over 5. Okay? All right, here we go. Okay? Find all 6 trig ratios here for an angle in standard position if a point with coordinates negative 1, negative 3 lies on the terminal side. Okay, so now because I'm giving you an ordered pair, we know exactly where this triangle falls. It falls in quadrant 3 because negative x, negative y. So I'm going to go over here and I'll draw my triangle in quadrant 3 again. So we're going to go left. And how do I know it falls in quadrant 3? Because I'm going left, -1, down, -3, okay, there's theta again. Now this time I will do real quick Pythagorean theorem. So -1 squared, okay, plus -3 squared equals c squared. So that's going to be 1 plus 9 equals c squared. C squared equals 10. Square root both sides, you get square root of 10. So there you go. So your hypotenuse is that. So now opposite over hypotenuse here. Opposite over hypotenuse. So that's going to be what? That's going to be -3 over root 10. Rationalize both. Top and bottom there, and you're left with just -3 root 10 over 10. Okay, cosine, same thing, adjacent over hypotenuse. So my adjacent side is -1. My hypotenuse is 10. Again, rationalize there. So your final answer is just -root 10. That's -1 times root 10 all over 10. Tangents, just opposite over adjacent. So opposite side, -3 over -1, which just equals 3. Okay, cosecant, I'm going to flip before I do this so then I don't have to worry about rationalizing. Okay, so I'm going to flip my first step here. So you just flip that and you get -root 10 over 3. Same thing here with cosine with secant because they're reciprocals. Just flip this first step here before rationalizing. And I'm just going to get a -root 10 because that's -root 10 over 1 is just -root 10. Cotangent, we're going to flip here, -3 over -1. So that gives you a -1 over -3, which is just a positive 1/3. Okay. All right. So here we go. I'm not going to spend a ton of time, okay, going over all these, okay? I'll do maybe a couple in detail. Again, guys, tomorrow on your test, you're having one question here on this, okay? If you can figure out what the midline is, what's the amplitude, stuff that we did on Monday, okay? Find the period, okay? You're going to be in great shape when it comes to that question, okay? So I'm not going to sit here. I'll write down the answers and stuff, but I'm not going to go over, okay? I'm not going to go over in detail every one of these. Otherwise, this video is going to be over an hour long, okay? So let's look at this first one right here, all right? Okay? First thing I always say to find is let's go ahead and let's find our midline. D is equal to the midline, okay? So how do we find the midline? D is equal to the max plus the min divided by 2. Max plus min divided by 2. So that means then D is equal to a So our maximum point up here is 4. Our minimum is -4. So you're going to get 4 minus 4 over 2. 0 over 2, so you get 0. So our midline is right here. Okay? All right. So now that we have our now that we have D, let's go ahead and find the amplitude. So remember, the amplitude is equal to the max minus the midline. So max minus midline. So max is 4 minus midline 0 is 4. Now, I am going to start right here at 0, 0. And since I'm starting mid, this is going to be a sine function since I'm starting at the middle. If I can start right here on the y-axis, it's going to save me a lot of time. We'll explain here shortly. Okay, but I'm starting right here, so therefore, since I'm starting max, middle, going to the max, back to the middle, down to the minimum, back to the middle here. I know it's a sine function. Remember, only 5 points. Middle, max, middle, min, middle. Okay? All right. So b is equal to 2 pi over the period. So the period, if you're not sure how to find that, okay, you just do end. You do your 5th point minus your 1st point. Fifth point minus the 1st point. So in this case, where's my 5th point end at? It ends at 2 pi. We're looking at the x-axis. So my 5th point ends at 2 pi. My 1st point ends at 0, and so therefore this is a period of 2 pi. So then when you plug that back in up here, you get 2 pi over 2 pi, which is equal to 1. So b in this case is 1. Okay, I want you to remember monthly temperatures. When we were doing the monthly temperatures, our C ended up being 7 because we chose the max for cosine, and that was in July, which is month 7. So look at, since I'm starting mid here, okay, since I'm starting mid here and x is equal to 0 here, then I don't have a C. C is equal to 0. Okay? So recall for our equations, it's y equals a sine b x minus c plus d. So our equation is going to be this. It's going to be y equals a, which is 4. Sine b is 1. So you can put in a 1 there if you want in front of the x, but you can just leave it like that. Okay? All right, real quick here, b. Okay, I'm going to go a lot quicker here. Again, I was able to start here, our midline. So d in this case is equal to 0 again. I'm not going to go through all the formulas. You can do that yourself. So d equals 0 here. Okay, I kind of really explained everything out in the first problem. All right. My amplitude in this case, A, is 1. If I go from the midline up to the max, it's 1. Midline down to the minimum, it's also 1. Okay. So this case now, we need to figure out a period. We need to write our 5 points. So middle, max, middle, minimum, middle. So my period in this case for this one here is my last point is pi, and my first point is 0, so that means it's just pi. So the period's pi. So then when you find b, b is equal to 2 pi over the period. You're just left with 2, so b is 2. And again, because I'm starting at 0, 0, okay? Again, because I'm starting at 0, 0, my c is 0. So again, we're using a sine function, middle, max, middle, min, middle. So we're going to get y equals 1a, so we just write sine x, sine. b, 2, x, and since there's no c and d, there's nothing else for you to do, and there you go, that's your equation right there. Okay? All right, so this one's a little bit tougher here. Okay, what you need to understand is that your intervals are going up by pi over 4. Okay, so we've got 3 pi over 4, 5 pi over 4, and then we've got 7 pi over 4. Okay, so we're going to start up here. We always start at max, min, We either start at max, minimum for cosine, or midline. There's no chance to start midline here unless we want to start right here at pi over 4. Okay, but we're going to start the max up here. Okay, and so we're going to go max, mid, oh, I'm sorry, I don't know why I'm drawing that there. Min, max, geez, I'm really sorry. Max, min, mid, max. Okay? So my midline, again, really easy to tell here. D is just equal to 0. Okay? Your amplitude is equal to 1. Okay, B is tough here because so your period, you take your fifth point, which is 7 pi over 4, minus your first point there, which is negative pi over 4. And so what that does for you is that gives you now 7 pi plus pi over 4, which gives you 8 pi over 4, which is 2 pi. So the period is 2 pi, so that means B then is equal to 2 pi over the period, which is equal to 1. We know our amplitude is equal to 1. Now this is where this is different. Where did you start? You didn't start at 0 anymore. You started your max at negative pi over 4. Okay? So then that means C, wherever C is, wherever you start on the x-axis, that is always your C. So recall our equation for cosine is y equals A cosine B x minus C plus D, plus or minus D. Plus or minus D, sorry. Okay? And so that's going to give me now y equals, A is 1, cosine, B is 1, so we're just going to do this. We're going to do x opposite when it goes in the parentheses, plus 4. And then D is 0, so we don't have to write anything there. So you just get y equals 1 cosine x plus 4. Okay? All right, so here we go. So D, okay, D. So look where we're starting here. Okay, we're going to start max up here. This is sweet. Okay, we're starting max up there. Okay, so we've got middle, min, middle, max. Okay. So D in this case, just real quick, how do you find it? Max plus minimum. So you've got what? 4 minus 4. So again, our midline right here at 0. So D equals 0. Okay. A equals 4 then. Again, it's positive because we're starting at the max. Max, mid, min, mid, max. So positive 4. D is 0. Okay, B in this case, the period, really easy to tell when you start at 0. So if you start at 0 and you end at 6 pi, your period is equal to 6 pi. Again, if you need to follow the formula from the first problem up there, do that. So that means B is equal to 2 pi over the period. So 2 pi over 6 pi gives you 1/3. Okay, C, because we're starting at 0 again, where's my x value? X value at my starting point is 0, so you get 0 there, and so your final answer is this. It's y equals 4 cosine 1/3 x. Okay? E. So this one here, what's my midline here? So we got D equals, my max is at negative 1. So we do negative 1 plus a negative 3. So negative 1 minus 3 over 2. that means D is equal to a negative 4 over 2, which equals a negative 2. So D is equal to negative 2. Now, your amplitude is your max minus your midline. So my max is at negative 1 minus my midline, minus, plus, so you get A is equal to 1. Okay? We're starting middle here, so we're starting midline, going to my max, back to my middle, down to my midline, down to my minimum, back to the middle. So we went middle, max, middle, minimum, midline, middle. Yeah, sorry, I'm having a tough time. It's been a long day today. Middle, max, middle, minimum, middle. So this is sine. Okay? So again, what's my period? I'm starting at 0 here, and I'm ending at 2 pi. So the period just equals 2 pi. Okay, so the period equals 2 pi. All right, so the period's equal to 2 pi, so then you can find B. B is equal to 2 pi over the period, so 2 pi over 2 pi, which equals 1. C again equals 0 because I'm starting on the y-axis. Okay, so we're using the sine function here, so my answer is going to be y equals sine x, and then just minus 2. There's no C value. B is 1. There you go. Okay. Okay, so for this one right here, I'm going to start minimum, middle, max, middle, minimum. Okay, so first off, let's find our midlines. Our midline, max is 3, minimum is negative 3, so then we know our midline is 0. So then that means my amplitude is equal to 3, but in this case, guess what though? We actually have a negative 3 because I'm starting cosine at minimum when it normally should start at the maximum. So I'm going minimum, middle, max, middle, minimum, so that's why you get a negative in front of the A. Okay? My period, we're starting at pi over 2 and we're ending at 5 pi over 2, so again, end minus the start. Okay, n minus the start, and so when you do that, you get 2 pi. Okay, so then again, B is equal to 2 pi over the period, so the period's 2 pi, you get 1. So you get B is equal to 1. C this time is a little bit different. Where am I starting at? I'm starting at, looks like pi over 2. We put in a pi over 2 there. Where did I start? I started right here. What's the x value? Pi over 2. Okay, and so you're going to get y equals negative 3. Sorry, this is a cosine graph, not a sine graph. I apologize. So cosine. Okay, b is 1. So you just do x. Opposite when you plug it back in. So it's a positive pi over 2, so this time it's a negative pi over 2. And there you go. That's your final answer right there. Okay? All right. Whew, halfway done. No, I'm just joking. We're way closer to being more done than not. Okay, G. Okay, same thing again here. All right. First off, let's find our midline. So looks like negative 2 to 4. So D is equal to 4 minus, so 4 is my max, negative 2 is my minimum. So 4 minus 2. So that gives you 2 over 2, which equals 1. So your midline is D equals 1. Okay, that means your amplitude up 3 to 4 down 3 to negative 2, so that means your amplitude is 3. Now I need to choose where I'm starting. Yeah, I'm going to start middle here. I'm going to start middle here, and since I'm able to go to max, middle, minimum, middle, yeah, so since I'm able to go middle, max, middle, minimum, middle, okay, I know it's a positive A, 3, okay. My period in this case, it's really tough to tell, guys, but if you start at 0 and you end at 3 pi over 4, sometimes finding your intervals helps you. Oh, we didn't end at 3 pi over 4. So what we really need to do is, if halfway is pi over 4, so if we know our middle point halfway is pi over 4, if we do pi over 4 divided by 2, yeah, this is messed up. Okay, I'm just going to go over this because, again, we've done so many of these. Your period should be 2 pi over 3. It's hard to tell. On the test tomorrow, guys, sorry, my mistake. On the test tomorrow, you will be able to see your lines very easily. So your period is 2 pi over 3. So then to find B, it's 2 pi over 2 pi over 3. And so when you do that, you get B equals 3. And then again, C, I started, what is x equal to here? 0. So here's your equation. You're doing sine. So it's y equals 3 sine 3 x plus 1. Okay? H, we're starting here and then we're going low, so middle, low, middle, high, back to middle. So this time it's nice, right? Yes, I went middle, low, middle like that. Okay, perfect. Yep. So middle, low, middle. Sorry, again, if you're looking at this, you got 5 to negative 3. So your D is equal to 5 minus 3 over 2. So that's 2 over 2, which equals 1. So our midline is there. Okay, at D equals 1. So then my amplitude is going to be from the midline. It's up 4 to get to the max, down 4. So our amplitude is equal to 4. Okay, this will be a negative A because I started mid and now I'm going low first though. So negative 4, positive 1. Okay, so we end at pi over 2. We started at 0. So your period is pi over 2. So B is equal to 2 pi over 2. And so you get 4. And since I started again at 0 here, C is just equal to 0. So here's your equation. You get y equals negative 4 sine, okay, 4x plus 1. Okay. Last one here. So again, we're going to start middle here this time. We're going to go max, middle, minimum, middle. Okay. So we can really tell in this one that our midline is equal to 0 because it's just 1 to negative 1, like we've seen a lot of those. We know my amplitude, A is 1. I did my normal behavior for sine, so I know it's positive. Okay, my b value, the period in this case, I started at 0 and I ended at pi over 2. So one cycle, the period is equal to pi over 2. So then b equals 2 pi over 2. Like we saw in this last one here, b is equal to 4. Okay? And then again, I start at 0, so c is equal to 0. Again, if you start at pi over 2, it would have been pi over 2. If I started at negative pi over 4, it's negative pi over 4. Again, this is a sine function, so we go y equals 1a for 1, so just sine. B, 4. X, there's no c and d, and so there you go. That's your final answer. Okay? Two graphing ones. Okay? Two graphing ones here. Okay? So, when we're graphing, when you have your graphing questions tomorrow on the first part here, A, B, C, and D are worth a point apiece. So recall, look at your formula, okay? Remember, remember what our formulas are. They're y equals A sine B, x minus c plus d, and y equals A cosine B, x minus c plus d. So in this first problem here, A is negative 3, which it can be negative, but remember, if I ask for amplitude, that's positive. B is 1. Do not tell me 0, because if you put a 0 in there, 0 times x will make it 0. When there is no value in between the sign and the x, that just means B is equal to 1.
Good afternoon, Milton Eagles. The following
Okay,
are the
C
bus
is equal to
change
0, and D
Students who write bus 4,
negative 2.
0, 8, 6.
So now let's go ahead and create our chart here.
4, 9,
4 by 6.
2. Students who write bus 4, 7, 0, 6.
First off, before we do
will now
that,
write bus 4, 8, 8, 9.
let's find our period.
Students who write bus 4, 5, 1, 5 will now write bus 4, 0, 9, 0. Have a good afternoon, Eagles.
So we've got 2 pi over b, so it just would be 2 pi, because it's 2 pi over 1, because b is 1. Intervals are the period over 4. So we got 2 pi over 4, which would then give you pi over 2. Okay, so now we do our chart, 4 by 6. So 1, 2, 3, 4, 5, 6, perfect. So we start at theta. Now, normally I start at my phase shift here, right? But since C is 0, you're starting at 0 here. And so then to get to your next interval here, you're just adding pi over 2. And so you get pi over 2. You add another pi over 2. So pi over 2 plus pi over 2 gives you 2 pi over 2, which then would just be pi. Add another pi over 2. So pi plus pi over 2 is 3 pi over 2. Add another pi over 2 there. So pi over 2 plus pi over 2, that's 4 pi over 2 or 2 pi. Okay? Don't forget your pattern here, because this is a sine function. Our pattern is 0, 1, 0, negative 1, 0. Okay, we're going to multiply by a here, which in this case is a negative 3. So everything from this row multiplying by negative 3. 0 times negative 3, 0. 1 times negative 3, negative 3. 0 times negative 3, 0. Negative 1 times negative 3, 3. Okay, 0 times negative 3 is 0. Okay, and then last but not least, because d is a negative this time, we're going to subtract d. So I'm taking everything from here and subtracting d, which in this case is a negative 2. So 0 minus 2 is a negative 2. Negative 3 minus 2 is a negative 5. 0 minus 2 is a negative 2. 3 minus 2 is a 1. 0 minus 2 is a negative 2. Okay, so let's go, and there's my y-axis there. Everything to the left is. So I just go halfway there. Okay? I'm going to go over every 2 for my x-axis, so that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we'll just scale our x and y axis going up by 1. So, like 1, 2, 3, 4. You get the point. Okay, let's go ahead and graph it. So remember, this is my x, this is my y. So my first point is 0, 2. Or not 0, 2, 0, negative 2, sorry. Okay, my next point's pi over 2, negative 5. Pi, negative 2. 3 pi over 2, 1. And then 2 pi, negative 2. There you go. There's your negative sine graph. Okay? All right, 19. Here we go again. So we know our formulas up top here. A, B, C. That means D is 0 here. Okay, that means A is 2. B is 2, and C opposite when you take it out, so pi over 4. So let's go with our period. So our period is equal to 2 pi over B. So that just gives me pi. Why is that important? Because that helps me with my intervals, which again is period over 4. So you get pi over 4 there. Okay, now that I have that, I can go ahead and draw my chart here. Okay, so that's going to be theta here. This is my phase shift. Okay, so my phase shift is where I start, right? C, right? It's always C. So you're going to start at pi over 4 here. Okay, and then your intervals are going to go up by pi over 4. So pi over 4 plus pi over 4 is 2 pi over 4, which gives you pi over 2. Okay, pi over 4 plus pi over 2 is 3 pi over 4. 3 pi over 4 plus pi over 4 gives you 4 pi over 4, which is pi. And then pi plus pi over 4 is 5 pi over 4. Okay, cosine this time. So remember, your pattern for cosine is 1, 0, negative 1, 0, 1. Okay, times A here. So times A, so 2 here, so A is 2. So we're going to take everything in this row, multiply by 2, so 1 times 2 is 2, 0 times 2 is 0, negative 1 times 2, negative 2, 0 times 2 is 0, 1 times 2 is 2. Okay? Normally we would add or subtract something to D here, but in this case D is just 0, so you don't have to worry about this row. Okay? So then this is your X, this now becomes your Y. So let's go ahead and let's graph. So here's my y-axis again. Okay, so we'll scale it going up. We'll just say every 2. So 1.
Good afternoon, Ms. Healy. Would you be able to
Two.
get onto a meeting with me for a few minutes? Again, can you get on a meeting with me for
Okay.
a few minutes? Thank you.
So 1 there, 2. And then we'll scale the x-axis going up by every 2 will be one of our radians. So pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. So my first point is pi over 4, 2, pi over 2, 0, 3 pi over 4, negative 2, pi 0, and then 5 pi over 4, 2. Okay? All right. At 8 a.m. on New Year's Day on Bermuda, the tide is in and reaches a depth of 3.8 feet. Okay, so what this means is, okay, when the tide is in, this is high tide. Okay, all right. All right, and then it says this. It says a depth of 3.8 feet under the pier in town. At 2 p.m., the tide goes out and reaches its lowest depth at 2.4. So this is low tide. So what do you think? Max, min, right? So we're starting at 8 p.m. here. Okay, so let's just go. I don't know. I want to see how do I want to do this. I can start it. Yeah, we'll just start here. We'll start at 8 p.m. Or start at 8 a.m., sorry. So 8 a.m. Okay. And then, yeah, let's do this. We'll start at 8 a.m. and we'll go. Actually, yeah, let's go up. We'll go up by that. So we'll start at, sorry guys, so we'll start at 8 a.m. So 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 11, 7, 8. Okay. Yeah, so here's how we're starting. So this is AM. This is PM right here. Okay. So what does it tell me? It tells me that my max, the tide, is at 3.8 feet. So we're going to go up here. We're going to say 3.8. So at 8. Okay, and then it says at 2 p.m. it's at, what is it, 2.4. Okay. So then what that means then is this is notice, okay? So from 8 to 2, how many hours is that? Okay, I know we only have our max and our min, right? But we're starting at our max and our minimum is halfway through. So that means then the high tide is going to be back at 8. At 8. So, what do I need to know to write my equation? Remember, I need to know y equals A. This is going to be a cosine graph because I'm starting at max. B, x minus c, okay, plus d, right? Okay, so that means then, where's my mid going to be? So it looks like 6 hours here. So what is halfway into 6 hours here? So 1, 2. So it's going to be somewhere in between 10 and 11, right? So how do we find my midline? Okay, well, let's do that. My midline so max plus min divided by 2, so D is equal to 3.8 plus 2.4 divided by 2. And so that gives me 6.2 divided by 2, so it's 3.1. So what would be halfway in between? So our midline's like right here at 10:30. Sorry, so 10:30, that's halfway. Okay, so there would be our midline. So then we go another 3.5 hours here. So right here. Okay, so that's our D value. All right, our amplitude is equal to the max minus the midline. So in this case, you would take 3.8 minus 3.1, which is equal to 0.7. Okay. Our period, how many hours did we cover from 8 a.m. to 8 p.m.? So our period equals 12 hours. So then B is equal to 2 pi over the period. To get 2 pi over 12, which is pi over 6. Okay? And then C, where did we start? We started at 8 a.m., right? Since we started at 8 a.m., C then is equal to 8. Okay, so let's go ahead and write our equation here. So we got y equals, okay, I'm going max to min, so I'm following normal behavior, so A is positive. So we got 0.7 cosine, B value, pi over 6, x, opposite C. So C is 8, negative 8. Okay, plus D, which is our midline, which is 3.1. Okay? All right, so estimate the depth of the tide at 6 p.m. Okay? So how many hours have passed to get to 6 p.m. when we started at 8 p.m.? So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So we're going to go ahead here and we're going to take, all we're doing here for this one is we're plugging in x equals 10. Okay, we're plugging in x equals 10 in there. Okay, so it looks like it's going to be this. So this is what you're going to put in your calculator. You're going to do y equals 0.7 cosine pi over 6. Please make sure your calculator is in radians because of this pi over 6 here. Okay, 10 minus 8 plus 3.1. So again, make sure my calculator is in radians. And I do this. I do 0.7 cosine of, so that's cosine of pi over 6 there. So let's do this. So cosine of pi over 6 times, this is a 2 in here because it's 10 minus 8 plus 3.1. Hit enter, and there you go. So it's around, so then it looks like it's going to be around 4.3. But I didn't get, why is that? Let's just do this. Maybe we do this, see if we get the same thing here. I don't know what's going on. I'm putting something on 0.7 cosine. how many hours? So 10 hours there? See, maybe since that's the first hour there, let's see what happens if I change that to a 1 here. Sorry guys. See what I get if I do that. So 0.7 cosine. All right, ours, okay, so after checking, sorry, I apologize. Our graph is fine. We just have to assume, I guess, that not till we get back to, well, I don't know, guys. I apologize. It's messed up. It should be, we need to treat it as, this equation is correct. Our equation is correct. We need to treat it as 18 hours as if we're taking it from midnight. Okay, so if we're starting, so we're assuming like this is starting at midnight. Okay, so then that would be x equals 18 hours. Because from midnight to 6 p.m., you get 18 hours. Because then when you do that, you get 3.45 feet. Okay, all right. Again, that'll be clear. You'll be able to understand that for the test. Okay, and then don't worry about D. It's not going to be on the test. Okay. All right. Long, but there you go. And good luck tomorrow. I'll see you guys tomorrow in class.